Welcome back to my lecture series in theory of probability. So, in the last class we have actually completed almost all the concepts related to permutation and combination. Now, today actually I will be doing some problems related to permutation and combination, just to give you an idea that where we are using those concepts, okay, and then only we will be able to move on to the next topic, right. So, you see I have taken some problems. The first problem, one by one we will be solving it on the board. The first problem, if you read the problem, it says that a person has got 12 acquaintances. A person has got 12 acquaintances, of whom 8 are relatives. Of whom 8 are relatives. So, out of those 12 acquaintances, 8 are relatives, right. Now, in how many ways can he invite 7 guests so that 5 of them may be relatives? So, you have to find out in how many ways can that person invite 7 guests. He has to invite 7 guests only, okay, but out of those 7 guests, 5 of them must be relative. Now, since 5 of them must be a relative, let's find out in how many ways I can select those 5 relatives, or how many ways I can invite those 5 relatives. Let's find out that way, because I have to have 5 relatives here. Now, how many relatives are there? There are 8 relatives. Now, from 8 relatives, there are 8 relatives, and you want to invite exactly 5 relatives. So, obviously you can invite 5 relatives out of 8 relatives in HC5 ways. HC5 will be the number of ways of inviting 5 relatives from 8 relatives, okay. So, 8C5 is the number of ways of inviting 5 relatives from 8 relatives. Now, once you have done that, now still you require 2 more guests, because you are actually inviting 7 guests. Now, since 5 of them are gone, so 7 minus 5, so 2 is left, but this 2 should not be a relative. Now, how many acquaintances you have? You have 12 acquaintances, out of 8 are relative. So, how many are non-relatives? So, 12 minus 8 is 4. 4 are non-relatives, right? They are non-relatives. So, obviously the 2 guests that you have to invite apart from the 5 relatives will be coming up from this 4 non-relatives, right? So, in how many ways that can be done? That can be done again by the combination principle, because you have 4 non-relatives and you have to invite 2 non-relatives out of 4. That can be done in 4C2 ways. So, 4C2 becomes number of ways of inviting 2 non-relatives out of how many? Out of 4 non-relatives, out of 4 non-relatives, right. So, 4C2 becomes the total number of ways of inviting 2 non-relatives from 4 non-relatives, and 8C5 becomes the total number of ways of inviting 5 relatives from 8 relatives. Therefore, what is the total number of ways that that person can invite 7 guests, so that 5 will be exactly 5 of them will be a relative? It will be coming by using the fundamental principle of counting, using the multiplication rule. Why? Because HC5 is the number of ways that I can invite 5 relatives, right. HC5 is the number of ways I can invite 5 relatives, and for each one of those HC5 ways of inviting 5 relatives, I have 4C2 ways. I have 4C2 ways of inviting the 2 non-relatives. Now, I need overall 7 guests to be invited, right. So, 8C5, so 5 relatives has to be invited and 2 non-relatives has to be invited also. It is not or, both the cases are and, this as well as this. So, since it is an and rule, therefore, I have to multiply the 2, and that will give me my total number of ways by which I can invite 7 guests from 12 acquaintances, of which exactly 5 must be a relative. So that will be my answer. This will be the answer. This is the total number of ways I can do it, and that you can calculate and find the answer. 8C5 into 4C2 gives the answer of the first question. So it is the fundamental principle of counting we have applied, the multiplication rule we have applied, and by which we actually come to the conclusion of this particular problem. Is it clear? Fine. If it is clear, we can now move on to the second problem. Now, if you look at the second problem says that at an election there are 5 candidates, okay? At an election there are 5 candidates, okay? And so there are 5 candidates at election. Let me write it down. Okay, there are 5 candidates at an election, and there are 3 members to be elected. So how many members to be elected? 3. So 3 members to be elected, right? Okay. And now the condition is a voter is entitled to vote for any number to be elected. So he has the freedom to vote for any number to be elected, right? Now in that situation, you have to find out in how many ways may a voter choose a vote. What will be the number of ways that he can choose a vote. Now how many candidates are there? There are 5 candidates, but you can elect only 3 of them. So, and since a voter is entitled to vote for any number of candidates, so we can think that there are basically 3 possible cases. Either the voter selects only 1 member, okay, or he selects 2, because he may give more than 1 vote, so he may vote for 2, or he may think that he may vote for 3, because 3 is maximum he can do, because there are 3 members to be elected, he cannot go beyond that. So there are 3 possibilities. Either he votes for all 3 of them, or he votes for 2 of them, or he votes for 1 of them. So 3 possibilities. There are 3 possibilities. Okay, 3 possibilities. The possibilities are, first is that votes for 3 of them, or is or between votes for 2 of them, or he may vote for 1 of them, So there are 3 possibilities. There are 5 candidates. He votes for 3 of them. So because he has the freedom of giving more than 1 vote as per the condition given on the problem. So but it's our rule, because you can understand that both the things cannot occur simultaneously. That's an absurd thing. He is voting for 3 of them and he is voting for 2 of them. That sounds absurd. So obviously it's or between the 3 cases. That means if I can find the number of ways for each one of these 3, and using the OR rule, that means addition rule, I'll get the answer. So my question is, how do I find out or what is the total number of ways of voting for 3 of them? Very simple. There are 5 candidates. And he is voting for 3 of them. So basically it's a selection of 3 things from 5 things. So he can do it in 5C3 ways. So this part he can do it 5C3 ways. So 5C3 ways he can vote for 3 of them. Now by same logic, he can vote the number of ways he can vote for 2 of them is 5C2, right? And the number of ways of for voting 1 of them will be 5C1, right? Because he cannot vote for more than 3, because there are 3 members to be elected, right? So therefore, so either this or this will be applied, because all 3 cannot occur simultaneously, or any 2 cannot occur simultaneously. Either this or this or this. So therefore, the total number of ways. Number of ways that he can elect those 3 members from a possible of 5 candidates at election will be 5C3 plus 5C2 plus 5C1. Just sum of those values, you will get the answer of this particular problem. So what we have done here is that we have used combination principle definitely, but it is basically the problem of the addition rule. We are implying the addition rule over here, because we have found out initially that there are 3 possibilities. Okay, either this or this. When you get an either or case, it is obviously the addition rule. When you get an and case, that this and this, then it's a multiplication rule always. So multiplication always stands for and. and addition always stands for OR. Okay. So, using the OR principle, we get to the answer of this question, which you can easily evaluate and get the answer. Clear? Okay. Now, we come to the third problem. Now, the third problem, we will just look at the problem over here. In how many ways can 5 oranges be divided between 2 boys so that each may receive at least 1 orange? Okay. Now, if you think carefully, that I have done a similar type of problem, not exactly similar, but the concept was more or less similar while I was discussing a particular concept of permutation in my previous classes. It is basically an extension of that. Now, in how many ways can 5 oranges? So, there are 5 oranges, right? There are 5 oranges. So, I write the data first. There are 5 oranges, and those 5 oranges are to be divided between 2 boys. So, there are 2 boys, right? There are 2 boys among whom I have to distribute these 5 oranges, and I have to distribute in such a way that each may receive at least 1 orange. That means each will receive minimum 1 orange. At least 1 means it can be 2, it can be 3, it can be 4. So, there won't be a case that any one of the boys not receiving any of the oranges. So, at least 1 he is going to receive. Now, in how many ways you can do it? Very simple. First, you see, you just select the first orange. Now, the first orange can be given to either boy 1 or boy 2. The first orange, if I pick up the first orange, I may give it to boy 1 or I might give it to boy 2. So, the first orange can be disposed in how many ways? Can be disposed in 2 ways. The first orange can be disposed in 2 ways. Either you can give this orange to the boy 1 or you give it to boy 2. You cannot give 1 orange to both the boy. You can either give it to boy 1 or you give it to boy 2, right? Same logic applies for orange 2. So, for orange 2 also there are 2 ways of disposing it. Either you give the second orange to boy 1 or you give it to boy 2. Okay. Similarly, for orange 3 also same thing happens. Orange 3, either you give it to boy 1 or you give it to boy 2. So, again there are 2 ways of distributing that particular orange to the 2 boys. Same thing happens for orange 4. For orange 4, there are 2 ways of distributing it. Either you give it to boy 1 or you give it to boy 2. And the fifth one, the fifth orange, because we have 5 oranges here, can again be disposed in 2 ways. That is, the fifth orange may be given to boy 1 or it may be given to boy 2. Right? It's OR, it's not AND. You cannot give 1 orange to both the boys. That's what I told you in the beginning. So, either you give it to boy 1 or you give it to boy 2. Right? So, in how many ways we can do that? First, you think about this one. How many ways you can do that? That is the principle which I have talked in some classes back, the concept. So, the first orange can be disposed in 2 ways. Second one can be 2 ways. All of them can be done in 2 ways. So, therefore, the total number of ways I can dispose these 5 oranges to these 2 boys will be, again using the multiplication rule principle of counting. There is 2 into 2 into 2 into 2 into 5 times, and that will be 2 to the power 5. So, 2 to the power 5 is actually turning out to be the total number of ways by which you can distribute these 5 oranges among these 2 boys. But that is not the question asked. Question asked is that each may receive at least 1 orange. So, each will receive at least 1 orange. Now, if you want to find that, you have to first find out those cases that whether any one of them is not getting any of the oranges. Now, is there any possibility? Yes, there is a possibility. See, there is one case where, in fact, there are 2 cases. Sorry, there are 2 cases. One case will be a case where you are giving all the 5 oranges to one boy and not giving anything to the boy 2, and the reverse situation. That means you are giving all the 5 oranges to boy 2 and not giving any of the oranges to boy 1. Are you getting my point? Because I want to find out at least one of the orange, so I have to find out those cases where the boys, either of the boys are not getting any one of them, and that happens in only 2 ways. One way is that you are not giving any of the oranges to boy 1 and giving all the 5 oranges to boy 2. Fine. The other case is you are giving all the 5 oranges to boy 1 and not giving any of the oranges to boy 2. So, there are 2 ways where you find that that this statement is contradictory. That is, the thing is that you are getting a situation where there exists a boy who is getting no oranges at all. So if I subtract those 2 from this 2 to the power 5, I will be left with the number of ways by which either of the 2 boys gets at least 1 orange, and that will be his answer. So my answer to this question will be, so the number of ways by which I can do that so that at least one of them gets 1 orange will be 2 to the power 5 minus 2. So that 2 is subtracted, because I think you understood that why 2 is subtracted. I repeat again, why 2 ways? Because one way is the suppose there is boy 1, suppose there is boy 1, there is boy 2, this is boy 2. Now first case, case 1, first case is that you are giving, I write 1 means 1 stands for I am giving the orange to the boy, 3, 4, 5, and cross means I am not giving the oranges to the second boy. So that means this is a possibility. I am giving all the 5 oranges to boy 1 and giving none of them to boy 2. Okay? Or the situation can be something else, like just the reverse situation. The situation can be reversed. We can do it here. That is, let's do it here. Let's say we have boy 1 here, and let's say we have boy 2 here. Okay. Now this time just the reverse situation. I am not giving anything to the first boy. Okay, all across, and giving all the 5 oranges to the boy 2. Now in these 2 situations only, I find that there will exist a case where one of the 2 boys are not getting any of the oranges. So these 2 cases has to be subtracted from 2 to the power 5 total number of ways to get the answer where I get at least 1 oranges. So that's the answer, 2 to the power 5 minus 2. That is the answer of this problem number 3. Is it clear? Okay. We come to the 4th problem. A cricket team consisting of 11 players is to be selected from 2 groups, okay, consisting of 6 and 8 players respectively. And how many ways can the selection be made? On the supposition that the group of 6 shall contribute no fewer than 4 players. No fewer means minimum 4, can be more than 4. No fewer means that is not less than 4, that is at least 4. No fewer than 4 means actually theoretically it is at least 4, can be more than 4 also, can be 5. I don't think that no fewer than 4 means exactly 4. Exactly 4 means only 4. No, it's more than 4 also is a possibility. So keeping those things in mind, let's see how we answer this question. It's a classic example of combination. Basically, I'll tell you this number 4. So first we write down the datas. Now we have to select a cricket team of 11 players, as we all know, 11 players aside, and the groups consist of, so this is group 1. Let's say this is group 1 and consists of 6 members, and group 2 consists of how many members? It consists of 8 players. Okay, 8 players. Now you have to make a selection in such a way such that the group of 6 means group 1, okay, shall contribute no fewer than 4 players. Now since they say no fewer than 4 players, so obviously there will be 3 possibilities in this particular problem. Why? Because the maximum member in group 1 is 6. So the first possibility will be 4 players from group 1 and the rest means 11 minus 4, 7 players from group 2. Are you getting my point? So 4 players from group 1 and in between, and it's 11 minus 4, that is 7. So 7 players from group 2. That is the first case. That is the first case, right? That is the first case we are getting, right? Now this is one case, that is a feasible case as per the question asked over there. Okay. The second feasible case is OR, the second case. Why is OR? Because both the cases cannot occur simultaneously. Either you have a selection of 4 players and 7 players, okay, that makes it 11, which is a cricket team. Or you may think of going for 5 players from group 1, okay, and so 11 minus 5, that's 6. So 6 players from group 2, that is also a possibility, right? And the third case will be 6 players from group 1 and 5 players from group 2. 5 players from group 2. Now that is the only that is the 3 possibilities possible, because we don't have more than 6 players in group 1. Had we have more players in group, group 1, we could have gone for some further combinations, but that's not possible. So we find that there are basically 3 possible cases, but only you can see that either the first case or the second case or the third case might occur. It's not that all the 3 cases will occur simultaneously. So since all the 3 cases cannot occur simultaneously, so therefore I have to find the answer using the addition principle of the fundamental principle of counting. But before I can use the addition principle, I need to find out the number of ways of selection of 4 players and 7 players, the first case. Similarly, I have to find out the number of ways of selecting this combination, and similarly I have to find out the number of ways of selecting this combination. Now that I can easily do it by using the combination principle. How? Now you see, now first case will be the first case. Now how many are there from group 1? There are 6 players, right? There are 6 players that are there from group 1, and you have to select how many players? 4 players. So you can select 4 players from 6 players in 64 ways. Agree? You can select 4 players from the group consisting of 6 players in 64 ways. Having done that, you have to select 7 players from the remaining group. The remaining group consists of how many players? 8 players, right? So from the 8 players, you have to select 7 players, and that you can do it 87 ways, right? That you can do in 87 ways. And what you see, there is a and between the two, and ampersand. And stands for the multiplication rule. That means this and this both are required. So therefore, it is 6C4 into 8C7. That gives me the total number of ways by which I can make a selection of a cricket team consisting of 4 players of group 1 and 7 players of group 2, right? In the very same logic, you can find the other 2. Now in the second case, I am selecting 5 players from group 1. So 5 players from group 1 means 6C5. 5 players from group 1 means 6C5. Having done that, we have to also select 6 players from group 2. That will make a cricket team only. So the second group has 8. So from 8 we are selecting 6, and that we can do in 8C6 ways. But again, there's an and between this and this. These are 2 events, and there's and. Because both the things are going to occur simultaneously, I need 5 players from group 1, and also I need 6 players from group 2. So therefore, it is 6C5 into 8C6. That gives me the number of ways of selecting 5 players and 6 players. And by same logic, I will be able to find out the last case, 6C6. 6C6, because 6 players are there, 6C6 is the number of ways I can select those 6 players from the first group, and again and between. So therefore, it's into 5 players you have to select now from the second group consisting of 8 players, so 8C5. So I have found out the number of ways of selection of this combination of players to form a cricket team. But I know now that either one of the 3 cases is going to occur. It's not that I'll be able to do all the 2 cases. It's absurd thing, because you can make only one selection. Okay, either this combination, or you might do this combination, or you might do this combination. You cannot do all the 3 simultaneously, right? So therefore, my total number of ways total number of ways in this particular will be coming from which principle? It will come from the addition principle of the fundamental theorem of counting. So the total number of ways will be 6C4 into 8C7 plus, because this or this, so 6C5 into 8C6 plus, we get 6C6 into 8C5. Okay, so you just calculate those values. Those are quite easy to find out, and you will get the answer of this question. That gives you the total number of ways by which you can make a selection of 11 players to form a cricket team from 2 groups, such that the condition laid down was that the first group, which is consisting of 6 members, should not contribute no fewer than 4 players. So that means 4 or above. That's what we have done. 4, 5 and 6, maximum 6 we can consider, because there are 6 players maximum in group number 1. So that is the solution of the 4th problem. Is it clear? Now we'll just end this with the last problem, which is a problem given from the IIT exam in 2007. You can see this question, a good question. You see, if you just go through the problem, the letters of the word Cochin are permuted and all the permutations are arranged in an English dictionary, mind it, English dictionary, then how many number of words that appear before the word coaching? So, how many words appear before the word coaching if you are arranging those words in a English dictionary? So, I think all of you know that how the words are arranged in an English dictionary is arranged in a alphabetically manner. So, let us write the letters of the word Cochin. So, Cochin is this, right? It's a name of city in Kerala. So, C-O-C-H-I-N, right? So, Cochin. Now, you see, basically what I have to do here is that I have to just write, just find out the arrangement in such a way that it is arranged in the form of alphabetically in English dictionary, right? So, as you can see, the alphabets are basically C. There are two C's over here. So, C, we have O, we have a H, we have a I, and we have a N, right? There are two C's over here, fine. Now, the thing is that what is if you want to arrange them this letters alphabetically, what should be the first letter? Obviously C, right? Then after C, what should be the next letter? So, after C, D, E, F, G, H. So, H will come, then E, F, G, H, I, then I will come, J, K, L, M, N, N will come, and then finally O will come. So, if I want to arrange them alphabetically with these letters only, this is the thing that will go. Fine. Now, I want to arrange them, I want to permute them. So, I can arrange with the word Cochin, I can do it number of ways. But the thing is that I have to now consider the arrangement and to find out that how many words are there before the word Cochin if I am arranging that in a dictionary after the arrangement has taken place, right. Now, obviously, the first letter will be C, because C is the first alphabet that will start, because it is the first alphabet, because C will come before H, I, N, O. So, C will be the first letter. So, there is no doubt about C that the letters will start with the word C, right. So, C is fixed in this particular position. So, I have no doubt about that, but still we are left with one more C, we are left with O, we are left with H, I and N. Now, the question is, there are how many places? 1, 2, 3, 4, 5, 6 places. So, I just mark them 1, 2, 3, 4, 5, 6. So, there are 6 places to fill up. Now, first position will be C. If I want to think in alphabetically manner, so by default it will be the first position will be C. No doubt about that. Now, what about the second position? Okay, before I come to that conclusion that Cochin is which word or what is the position of the word Cochin, right? Now, in the second position, as you can see, we are left with these 5 letters, right? C, H, I, N, O, right? Now, obviously, if you have to form the word Cochin, the alphabet O should come over here, but O will not come here after this. Why? Simply because H, C, H, I, N all are preceding the alphabet O as per the English alphabets. So, in this position, we can fill up by either C or H or I or N. So, there are 4 ways that I can fill up this particular place. Okay, before I can fill up the alphabet O to form with the word Cochin, right? Now, the thing is that to fill up this position, there are 4 ways are there. Okay, there are 4 ways are there. Now, so there are 4. So, the 4 ways are either you can fill up this here by the alphabet C or H or I or N. So, there are 4 ways you can fill up this particular place. Now, for each one of the now let us say I fix up the letter C over here. If I fix up the letter C over here, now these 4 places can be filled up in how many ways by the remaining 4 letters? In factorial 4 ways, in 4p 4 ways, there is factorial 4 ways, because I can arrange this remaining 4 in factorial 4 ways. Okay, so factorial 4 ways I can arrange by fixing C in the second position. Same thing happens by fixing H in the second position, again factorial 4. For fixing I in the second position, again factorial 4. For fixing N in the second position, again factorial 4. So, that means now after doing that, after doing so many combination, so many permutation, then after C, H, I and N has been inserted in the second position, now the last will be O, because O will be at the last, because O comes as per the alphabet is given over here with the word Cochin, O will come at the last. So after fixing C, H, I, N, okay, in the second position, now O will come. So O will come in the second position. Now if O comes in the second position, then I get O over here, and when O comes in the second position, then automatically the first word will be Cochin, because you see the leftover. So among the leftovers, C, H, I, N, if you look at it very carefully, if you look at it very carefully, the moment O comes after inserting C, H, I, N, O comes here, and automatically this will be arranged in that alphabetically order. C, H, I and N will come, and so this will be the position of the word Cochin. So then I have to find out that how many such arrangements are there before I come to this conclusion of Cochin. That is very simple, because just now I told you that my second position can be filled up by either C, H, I and N, and for each way of filling up the second position by C, H, I and N, there are factual 4 ways of filling up the remaining 4 positions. So therefore the total number of ways of permuting this will be 4 into factorial 4. So it will be 4 into factorial 4. So 4 into factorial 4 is 24. Okay, so it is 96. 96. So 96 arrangements can be made, okay, before the word Cochin. So Cochin will be actually the 97th word in this arrangement if you want to arrange the words in the form of an English dictionary, that is in the alphabetically. So that is the explanation. Okay, is it clear? So I repeat again, in my after, because C will be by default in the first position, because C is preceding among all the alphabets. Second position will not be taken by O, because C, H, I and N are preceding over O. So if C is over there, the remaining 4 can arrange among factorial 4 ways. If H is there, factorial 4, I is there, factorial 4, N is there, factorial 4. So 4 into factorial 4 is 96. So 96 arrangements will take place. Now after the 96 arrangement takes place, now the second position will be taken by O, obviously, because C, H, I, N has been inserted. As per alphabetically, O will now come. Now if O comes in the second position, okay, then by default the word will be Cochin, because immediately in the third position C will come, because C is preceding over H, I, N, H is preceding over I and N, I is preceding over N, and Cochin comes automatically after 96 arrangement. So Cochin will be the 97th word. The 97th word, or 97th arrangement actually. The 97th arrangement will be actually the word Cochin if you are arranging the alphabets of the word Cochin in the form of an English dictionary. Is it clear? So I think I have given you some idea related to permutation and combination with these 5 problems. So that's all for today's class. Next class also we will be discussing a few more problems before we will go into the concept of set theory. Thank you very much.